as we look at our equations in standard form, we want to make sure we understand whether our equation is a linear equation or if it is representing something else. So when we have a linear equation, the key word here is linear. That means line. So we are going to have a graph that is going to be a straight line, whether that's horizontal, vertical, or at a diagonal. It's going to be some sort of straight line. These all fall under linear. These others, you might see something that has a parabola, some sort of U or funny shape, or something that has several curves in it. Those are non-linear equations. And so we'll look at those more as we get into the second semester of algebra. But looking just at the equation, we can determine whether something is linear or not. So when we look at ax plus by equals c, we're going to look for a couple of things. We're going to look and check to see that x and y both have exponents of 1. Exponents are that little number that sits just to the upper right-hand corner of a variable or even a number. So if I just see x by itself, that is the same as x to the first power. If I see y by itself, it's the same as y to the first power. And that's okay. We are happy with that. If it's a different number, that's when we're going to have problems. We don't want it to be a different number. It either just needs to say x or y, or x to the first power or y to the first power. The other thing we're going to need to avoid is x and y not being multiplied together. We cannot have x times y. That is a big fat no. We don't want that to happen. We do not want those two things to be multiplied together. So we are looking for x and y to not appear in denominators, denominators being numbers in the bottom of a fraction or with division. So for example, 5 over x, we do not want that to happen. As I said, we do not want exponents, so we don't want to say x to the third power or y to the fifth power. And so we don't want to see anything like that happening as well. And then lastly, we do not want to see radical signs. So we don't want to see any square root symbols, etc. So those are things we want to avoid. If you see those, then it is not linear. So if we look at these examples, we've got exponents happening here. We don't want that. We have x and y being multiplied. That is the part we don't like. We have x in the denominator. That is not allowed. We have x being used as an exponent, also not allowed. And then we have a radical. So none of these situations are linear. We don't want any of this to happen. So when we're checking for a linear equation, you can check it up against these examples and say, oh, is it similar to that? Is it not similar to that? Well, let's decide. Let's look at a few examples. In that upper right corner, I'm going to jump to the top. We're going to look at a few examples of how to determine if something is a linear equation and then how to put it in standard form if that part is true. So again, in standard form is ax plus by equals c, where a has to be greater than or equal to 0. So it needs to be a positive number, a positive whole number. And so as we go through these, we're going to go through our checklist of linear equation requirements and then put it in standard form if it is. So looking at example 3, we have y equals 2 minus 3x. So the things we want to check for that we just spoke about down here is that x and y both have exponents of 1. So we don't see any other exponents like 2, 3, 4, that x and y are not multiplied together, and that we don't see x or y in the denominator in an exponent or with a radical sign, so a square root symbol. So that's what we're checking for. So looking at example 3, I don't see x or y being multiplied together. I do not see any exponents of any kind. I don't see any square roots, and I don't see x or y in the denominator. So I'm going to say that, yes, this is linear. And then I'm going to need to put it into standard form. So I'm going to take the original form of our equation, y equals 2 minus 3x. And my goal is to get a and y on the same side and make the a, which is the number in front of x, positive. So looking at this, I'm going to move the 3x by addition to the other side of the equal sign. And we end up with 3x plus y equals 2. We just, again, want to double check that a is not negative. We have no fraction numbers. We have all numbers, all whole numbers. And that I can't divide anything out. So 3, 1, and 2 have a greatest common factor of 1. There's nothing I can divide out. So we are done. This is our final answer for example 3. We're going to do the same steps for example 4, 5, and 6. Looking at example 4, again, going through the checklist. Do I see any exponents? Do I see square root symbols? Do I see x and y being multiplied together? Do I see x or y in the denominator of a fraction? I don't see any of those happening. And so I will say that, yes, this is linear. And so we are going to want to put this into standard form. We're going to start by combining like terms, getting all of our x's together. So I'm going to subtract 3x. We have 5x minus 3x, which gives us 2x plus 6y equals 2. For standard form, we want a to be a positive whole number or 0, so it must be greater than 0. It's not negative, so we're set there. It's a whole number. And we want to check to see if I can divide anything out. Well, 2, 6, and 2 have 2 in common. They are all divisible by 2. So we are going to divide everything by 2. And when we do that, we get x plus 6 divided by 2 is 3. Y equals 2 divided by 2 is 1. And that is our final standard form equation. X plus 3y equals 1.